As you expand your Azure network design, you will likely come across situations where multiple virtual networks need secure access to shared external resources, like on-premises networks or other Azure VNets. Instead of deploying a VPN gateway in every virtual network, you can take advantage of gateway transit and remote gateway to centralize connectivity and reduce complexity. When you enable gateway transit in a virtual network, you are allowing its VPN gateway to act as a connectivity hub for other peered virtual networks. Think of it like this. You set up one virtual network with a gateway, and all other peered networks can use that gateway transitively to reach external networks. This approach is especially useful in hub and spoke architectures where the hub network contains the VPN gateway and the spoke networks peer with the hub and rely on it to reach the internet, on-premises networks, or other VNets. When a peered virtual network uses the gateway of another VNet, it is said to be using a remote gateway. From the spoke network's perspective, you are not hosting the VPN gateway yourself. You are simply consuming the gateway resources of the hub network. You configure this during VNet peering setup by selecting the option to use a remote gateway in the peering configuration. This tells Azure that your VNet is delegating gateway connectivity to the peered network. This diagram shows you exactly how gateway transit and remote gateway work together in a typical hub and spoke architecture. We are working with three virtual networks here: Virtual Network A, Virtual Network B, and a hub virtual network. The hub is the central point, and it's where you've deployed a VPN gateway to connect your Azure environment to on-premises infrastructure. Instead of placing VPN gateways in every virtual network, you allow the hub virtual network to share its gateway by enabling gateway transit. This means that other VNets peered with the hub can use that gateway to reach external networks. In this setup, Virtual Network B is configured to use a remote gateway, which means it doesn't need its own VPN gateway. It simply uses the one in the hub to connect to on-premises resources. On the other side, Virtual Network A is using a user-defined route to direct traffic to the hub. This could be for scenarios where you want traffic to pass through a network virtual appliance, or where you want tighter control and inspection before traffic exits through the VPN gateway. In this architecture, we have configured peering between all three networks, which is essential for this kind of connectivity. The hub allows gateway transit, and the spokes either route traffic explicitly, like VNet A using UDR, or use the remote gateway setting, like VNet B. With this model, we have created a clean, scalable, and secure network design where the VPN gateway only lives in the hub, and everyone else just plugs in and benefits from that shared connectivity. This setup saves you cost, simplifies your architecture, and ensures that all communication happens privately over the Azure backbone without needing public IP exposure.